All right, good morning, guys. Um, we're starting on page 133 in your books. Lesson 2.7, Analyze Linear Equations, y equals mx. So it starts off with this example of a group of college students developed a solar-powered car and entered it into a race. The car travels at a constant speed of 100 meters per 4 seconds. What representation can show the distance the car will travel over time? Whenever we're talking about representations here for these situations, you have one of three options. You could make a table, you could make a graph, or you can write an equation. The equation is going to be the expression that we write for part B. If you were to show this using a table, for instance, we are looking at comparing distance versus time. Or you can swap those around. Time in the top row, distance in the bottom row. Doesn't really matter. The information that it gives us is that it can go 100 meters in 4 seconds. If we wanted to fill this out with some other values, we could do 200 meters would take 8 seconds. 300 meters would take 12 seconds. If we determined the unit rate, which would be its speed, we would divide any of these pairs and have 100 meters in 4 seconds would give us it's traveling at a speed of 25 meters per second. So I could put this in my table as well and show 25 meters in 1 second, or 50 meters in 2 seconds, and so on. Graphically, if we were to show this, you would graph this with time on the x-axis and distance on the y-axis. The first point that we'd put is at 0, 0. If no time has passed, it's not going to go any distance. And then however far out you want it to go, if each of these tick marks is 1 second, that should also be labeled here. Distance in meters. I would say maybe this is 100. My graph is not great, but 1, 2, 3, 4 seconds takes us to 100 meters. And then I can draw my line. The expression that's going to show the distance the car will travel over time is going to be in the form y equals mx, which is why that is part of the title. Previously, we talked about the equation for proportional relationships, and that was y equals kx. Now we're talking about y equals mx. These are the same exact equation. Your constant of proportionality, which is k, is the same exact thing in these scenarios as the slope, which is m. So k equals m, same exact thing. Our equation, in this case, the value that we're going to plug in for k or m, whichever one we want to use, is the unit rate, which was 25 meters per second. So our equation for this scenario is y equals 25x. Or if we want to use distance and time, we could say distance equals 25 times time. For part C, compare the representation and the expression. Which shows the distance traveled over time more clearly? This is going to be your personal opinion. You decide which of these representations, either the table, the graph, or the equation, makes the most sense to you to show this relationship between distance and time? For me, the one that shows it most clearly is the equation. My brain works with the numbers. That's easier for me to conceptualize. If the graph is better for you, great. If the table is better for you, awesome. Doesn't really matter. There's no right or wrong answer for this. You decide which one you like the best. For the focus problem, we're not actually going to answer this one, like finding the number, because the conversion here is not super nice. But how would the representation or expression change if the speed was converted to miles per minute? The values that we'd plug in for time would change because now we're looking at minutes instead of seconds. And the output that we get is going to be different because we're looking at miles instead of meters. But in general, it's going to look very similar. The graph is still going to be a straight line that goes through 0. Your equation, the y equals 25x, is still going to look very similar to that. You are just going to have some other rate in there in terms of miles per minute instead of meters per second. I will give you some extra credit if you can correctly convert the 25 meters per second into miles per minute. I'm not going to show you how to do that right now, but if you can figure that out and get the correct answer, I will give you some bonus points. Moving on, next page. So the essential question for this lesson really is, how does the slope relate to the equation for a proportional relationship? Okay, our question up here. So like I said on the previous example, your equation for a proportional relationship is y equals kx, where k is your constant of proportionality. That is the same exact equation as the one using slope, y equals mx, m representing slope. They are the same exact thing. When we have a constant, or when we have a proportional relationship, these two equations are the same exact equation. Slope is your constant of proportionality. Unit rate, constant, slope, they all mean the same thing. So when we look at this scenario of looking at the cost of fencing per foot, they give us 3 different values on here showing that 6 feet of fence is $30. So going off of that one, $30 for 6 feet of fencing, equals $5 per foot. Okay, in each of these pairs of numbers, if we divide them, do the dollars divided by feet, 75 divided by 15, you're going to get $5 per foot, and $120 for 24 feet, again, $5 per foot. So this relationship is a proportional relationship. Our constant of proportionality is going to be 5. Well, that also means that the slope is going to be 5. And the question that they ask is, how can they use the pricing for the different lengths of fencing to determine the cost for 50 feet of fencing? Based on the information that we were given, we found that the fencing costs $5 per foot. So 50 feet of fencing would be 5 times 50, or $250. Now, the different representations that they use to find this, I've just shown you using the ratios. Step 1 here, they have the graph with all of these points on it. Because we have a straight line going through 0 that shows a proportional relationship, okay, 0 feet of fencing would cost you $0. They've already put these 3 points on here for 15 feet, 24 feet, and 35 feet, even though we did not have 35 feet in our list here. several different ways that we can also come to the slope or the constant from this graph. So they're showing using 2 points and finding the run and the rise to get to the next point. Run versus rise. When we have a proportional relationship, we can certainly do that to find the slope, or we can pick any one of these points and use those values to help us find the constant of proportionality. So I'm going to pick this third point at 35, 175. That's our x and y value. And I can find my constant or my slope by doing y divided by x. So 175 divided by 35 also gives us 5, which tells me that the equation for this graph is y equals 5x. We can also use our definition for slope that it is rise over run to determine the slope of this line. When we have any 2 points, we can find the horizontal distance between them and the vertical distance between them, which is our rise and run, or run and rise. And again, we can pick any 2 points. They've shown the rise and run between the first 2 points and the rise and run between the second and fourth points. If I want to pick a different pair of points just to really drive the point home here, I would go from maybe the first point to the third point. And I typically like to do the rise first and then the run. So I would determine from that first point to the third point how far up I have to go and then how far over I have to go. Keep in mind when you're doing this that we are not just counting like how many squares, but you're actually looking at here the y values that correspond to that distance. So this first point is going from a y value of 75 up to a y value of 175, giving me a rise of 100. And then the run, we are going from a horizontal value of 15 to a value of 35. So the run there would be 20. So if we do our slope as rise over run for these, that's not the right letter. There we go. The rise over run for these pair of points, my rise was 100, the run is 20. We divide those, again, we get 5. So long answer short, 50 feet of fencing costs $250. Now, on the try it, you do have the first problem on your homework is like almost exactly like this, same exact setup with the boxes and everything. Adley, I know you don't like using them, but it will be helpful on this one because it's helping us determine which points they want us to use and where they go in this equation. If you recall from the last section, I think it was the last section, our formula for slope is y2 minus y1 over x2 minus x1. When we use the formula, the first values here in both of the subtractions belong to the same point, x2 and y2. And then your second values also belong to the same point, x1 and y1. So in the boxes here, the way they've got this set up, is that these two values go together. That this is the x-coordinate that goes with this y-coordinate. And the same in the second set of boxes, that this is another x-coordinate in the denominator that goes with the corresponding y-coordinate in the numerator. So on our graph, if I'm looking at what's going to go in the box on the bottom here, I'm going to find where my y-coordinate is 80. So my y-axis at 80, I'm going to go over to that point. That corresponds to an x value of 4. That is going to go in the box on the bottom. Then my other point is going to have the x-coordinate of 3. So go to my x, go up to my line. That corresponds to the y value of 60. Then we just do the subtraction. 80 minus 60 is 20. 4 minus 3 is 1. So 20 divided by 1 gives me my slope of 20. The equation is y equals 20x. Under your convince me, how do the equations y equals mx and y equals kx compare? They are the same exact thing. They're the same equation. They mean the same exact thing. And moving on to the next page. On your vocab sheets under slope, I would, if you have room, add this information here. I did not include a separate box for positive slope and negative slope, or even somewhere on that page down at the bottom. Draw an example of each of these. Lines that slant upward from left to right have positive slopes. So in any graph, if your line goes this way, that has a positive slope. If your graph has a line that slants downward from left to right, like so, it goes through 0, that is going to have a negative slope. So I would make sure you have an example of that somewhere if we don't already. In this example, again, we're just looking at finding the equation of the line for this scenario. So they picked 2 points at 3, negative 750, which is here, and the second point at 2, negative 500, which is here. Okay, your rise over run, if we want to just look at how we get from one point to the next, I would go down and right. And again, we're not just counting squares. This is not 2 and 2, because we want to look at what those values actually represent on the axis. The top point going from negative 500 to negative 750. This is going down 250, and then it's going right 1. Okay, doing the subtraction over here, negative 750 minus negative 500. Keep in mind that when we are subtracting this negative, you're adding them. Gives us negative 250 over 1. So the slope is negative 250. We put that into the equation for m, and that's our final answer. Make sure if you have the graph and you can see that it's going down and to the right, that your answer that you get for the slope is a negative number. And likewise, if it's going up and to the right, you want to make sure that your slope is a positive number. Graphing equations, when you're just given the equation, these are actually easiest when we have a fraction. I know that you guys don't like fractions, but it makes it easier. So this slope of 1/2 means that we have a rise of 1 and a run of 2. So if we're starting at 0, 0, that tells me that I am going to go up 1 over 2. Up 1 over 2. You continue doing that until you run out of graph. Put as many points on there as you can, and then you will use a straight edge to draw your line. Okay, try it problems. When you're doing these, whether you're graphing or you're writing the equation, first off, pay very close attention to the scale on your axes. Okay, for part A, each box on the x-axis is worth 5. Each box on the y-axis is worth 2. So you need to keep that in mind when you are finding your slope. If they don't have points labeled on here, then you want to pick where the line is going through a nice intersection of the grid lines. And there's several on here that we could use. I would maybe go with this point at 10, 4. Finding your slope. Let's say we start at 0, 0. We can do this by just looking at the graph and deciding how far up, how far over are we going. If I'm going to determine my rise over run, direction-wise, I am going up 4, so it's a positive 4, and it's running positive 10. 4 over 10 reduces to 2/5. Always, always reduce your fractions, but do not turn them into decimals. Once we have found our slope, then we just put that in the equation. Y equals 2/5 x. Done. For B, when we graph, because these are all proportional relationships, they are all going to start at 0, 0. So we start there with our first point. Then we're going to use our slope to be able to find all the other points that are going to fit on this graph. So your slope of -3, if your slope is an integer, turn it into a fraction by putting it over 1. In this scenario with a -3 over a positive 1, this tells me that the directions to get to my next point, rise and run, I'm going to go down 3 and right 1. If you have a negative rise, that's always going to indicate going down. A negative run is going to indicate that you're going left. So from that first point at 0, 0, I am going to go down 3, right 1. Again, we need to pay very close attention to our scale. On our x-axis, these are going by 1. On our y-axis, these are going by 2. So if I'm going to go down 3 and right 1, I'm going to go 1, 2, 3, and right 1. 1, 2, 3, right 1. Until I run out of graph. I also want to go the other way because my graph doesn't just start right here. This is not a situation where we can't have negatives. So the other way that I can do my slope, if this is a -3, the negative could also go in the denominator instead of the numerator. So now my rise is a +3, which is going to indicate going up 3. My run is a -1, so that's going to tell me to go left 1. So if we go back to 0, 0, now I'm going to go up 3, left 1. And I'm going to continue doing this until I run out of graph. Once I have all my points on there, I'm going to get out my handy dandy ruler and line it up. That's not very good. Draw my line. Make sure that you are using a straight edge. If you don't, I will tell, and I will probably not mark it wrong, but admonish you to use a ruler. Or anything that's straight. It doesn't have to be a ruler. Anything that has a straight edge will work. Okay. Finally, I want you guys to take a couple minutes to do 4 and 5, talk about your answers together before you move on to the homework. You can go ahead and pause this. I will do the answers here so you can check yourselves, but don't be a cheater pants and just wait for me to do the work for you. I want you to try it on your own and then see how you do. So if you have paused and tried the problem yourself, on part A, the constant of proportionality for the line is 30. The hiker gains 30 feet of elevation for every minute that they hike. So K is 30. That means the slope is also 30. And therefore your equation would be y equals 30x. For the graph of the equation, y equals -1/2 x. When your slope is a -1/2, that means that the negative goes with the 1 or it goes with the 2. Either one of these is acceptable, and in fact we want to use both of these representations. The first one would tell me that I'm going to go down 1 and right 2 from 0, 0. So we put our point at 0, 0. On this graph, each box is 1 on the x and the y axes. So I can just go down 1, right 2. I can fit 2 points on there. And then my other representation of slope 1 over negative 2 means I could go up 1 and left 2 from 0, 0. So I'll do that. Again, get my ruler, line it up, and draw your line. If you have successfully done that, well, or unsuccessfully, doesn't really matter. Either way, you're going to do page 137, 6 through 14. Again, on 6, this is just like that first example we did, where they're giving you the points that they want you to use. The 280 is going to go with that x value that you need to find. The 2 is going to go with the y value that you need to find. Plug those in, find your slope, and convert that to your unit rate. So, best of luck. If you have questions, you can email me, and I will hopefully be able to see that and respond to you in as close to real time as possible. Otherwise, we can go over it tomorrow if you have any other questions. Check your work as you go. Mrs. Hollowell has the answer key. I'm okay with you guys checking this as you go to make sure that you're on the right track. Good luck. I'll see you guys tomorrow.